Wamsted. This is my house. Good morning, good afternoon, whatever. Welcome back to 8th grade math with Mr. Wamsted. I am Mr. Wamsted. Today, we are gonna watch a couple videos about angles because I realized the other day we just didn't have that down yet. So we're gonna watch like a string of 4 short videos about adjacent angles, vertical angles, supplementary angles, complementary angles, and probably some other kind of angle that I'm forgetting, maybe with parallel lines too. I know there's 4 videos. So we are going to sit back and it's going to be clips from each video. And then at the end of all that, we're going to come back and talk a little bit about our assignment. Our assignment is going to be on whiteboard, but maybe also on paper a little bit too. Anyway, you'll see when we come back. Anyway, sit back right now and enjoy these videos. I'm not going to try to tell you who they're all from, but I will leave their names up, so you should check them out. All right? All right. Now.
Adjacent angles are right next to each other. Now, they're 2 separate angles, but they are right next to each other. They're like neighbors. So if we take a look here, angle LNM is adjacent or next to angle ONM. So again, these angles are 2 separate angles, as you can tell. It looks like angle LNM is an acute angle, while angle ONM is an obtuse angle. And again, they are right next to each other, and they share one of their rays.
So it's almost like thinking about neighbors sharing a fence that's between the 2 yards. So there's 2 different angles sharing that fence or that ray.
When 2 lines intersect in geometry, they form 4 angles. Vertical angles are angles opposite each other. Any 2 intersecting lines form 2 pairs of vertical angles like you see here. A quick look at this drawing brings up several questions. Are vertical angles congruent? Are vertical angles adjacent? Are vertical angles supplementary? Are vertical angles complementary? Let's tackle these one at a time. Take 2 straight objects like pencils and place them so that they cross. Now, look at the angles they form. If you study any pair of these opposite angles, you will see that they share a common point at their vertices, their corners. That makes them vertical angles. You will also notice that large or small, they seem to be mirror images of each other. That's because they are. They are the same angle reflected across the vertex. Vertical angles theorem states that vertical angles, angles that are opposite each other and formed by 2 intersecting lines, are congruent. So when someone asks, are vertical angles congruent, you already know the answer is yes. According to vertical angles theorem, no matter how the pencils cross or how you draw 2 intersecting lines, vertical angles will always be congruent. How about the question, are vertical angles adjacent? Vertical angles cannot, by definition, be adjacent, next to each other. Another pair of vertical angles interrupts since opposite angles are vertical. Adjacent angles take one angle from one pair of vertical angles and another angle from the other pair of vertical angles.
2 angles are complementary if the sum of their measures is 90 degrees. And 2 angles will be supplementary if the sum of their measures equal 180 degrees. Yes, that's how simple it is. Look at these 2 angles. 35 plus 55 is 90. So yes, they are complementary angles. If the sum of 2 angles is 90 degrees, then they are complementary. Look at this figure and try to name the 2 complementary angles. Here, we are given that angle ABC is a right angle, which means it measures 90 degrees. It means the sum of these 2 angles will surely be 90 degrees. So angle ABD and angle DBC will be complementary angles. Remember, if the sum is 90 degrees, then angles are complementary. Here's another pair of angles. 120 plus 60 is 180 degrees, which makes them supplementary. And this figure, in which line MP is a straight line, also has supplementary angles. Angle MNO and angle ONP are supplementary. Notice that these two angles are supplementary as well as adjacent. Adjacent angles which are supplementary form something called a linear pair. The two adjacent angles form a line.
So parallel lines are lines that will never cross, even if they go on forever. But what if I take one of our lines and give it a little nudge? Now the lines aren't parallel anymore. In fact, they cross at this point right here. Let's name it point P. When lines cross at a point like this, we say that they intersect, and we call the point an intersection. And when lines intersect, they form angles. You can think of the angles as the spaces or shapes that are formed between the intersecting lines. These intersecting lines form four angles. 1, 2, 3, 4. But instead of calling them angle 1, 2, 3, and 4, in geometry, we name them by the points used to make them. For example, this angle here can be called angle DPB because if you trace along those points, like connect the dots, they outline that angle. And this angle here, we can call that angle APD because connecting those dots forms that angle. Now when naming angles, there's a nice shorthand that we can use. Instead of writing the word angle over and over again, we can just use the angle symbol instead, which looks like this. But there's an even simpler way to name angles. To learn that way, let's erase all the points and letters on our lines except for the intersection point and this one point here. Now let's imagine that the line segment between these 2 points can rotate around the point of intersection just like a clock hand rotates around the center of a clock. Let's also imagine that as we rotate the line segment, the point out at the end leaves a trail, like if a pencil was attached to it. The trail, or path, that's left when we rotate the line segment all the way around forms a circle. But if we only go part way around, then it forms part of a circle that we call an arc. This arc can represent the angle that's formed when we rotate the segment from one position to another, like from this line to that line. And now, if we shrink down that arc so that it's close to the intersection point, and then put a letter by it, like the letter A, we have another way of showing an angle, angle A. And we can do this with any angle. So the angle up here, we can also draw an arc and call it angle B. So whenever you see a letter next to a little arc like this, it means that it's the name of the angle formed by that arc. All right then, so now we have a diagram that shows angle A and angle B. And you might notice that those angles aren't the same size. B seems to be bigger than A.
All right, yes, that was amazing. I hope that helped settle some of these issues about angles. It is a lot of words: acute, obtuse, right, straight, complementary, supplementary, adjacent, vertical, right. So many. I just can't even name them all. I hope that helped clean it up. We're going to go do an assignment right now that hopefully should clean it up even a little more. And that assignment is, we're going to do it half on whiteboard, half on paper, meaning some people don't like doing it on whiteboard. They can just do it on paper, but I am going to ask you all to go to whiteboard here in just a minute so we can do it. All right. So I'll meet you guys over there right about, well, now.